Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all of us into my discussion today. I'm going to look at the determinant of a 3 by 3 matrix by elementary scheme. Now, in this case, we are going to be using our previous knowledge, which we have looked at the concept of determining a matrix or finding a determinant of a matrix. And this is going to be creating for us a basis for trying to, of course, understand this specific aspect of elementary scheme for determining a matrix of a 3 by 3, which is basically a square matrix. Now, in our previous discussion, we had decided that we're going to consider matrices of the form of either a 2 by 2 or a 3 by 3, which we said that basically for us to find a determinant, the determinants are going to be, of course, defined on what we refer to as square matrices. Now, in a sense, in this video, we're going to look at the second case, but I'm going to borrow from the first discussion which we had in representing the elements of a matrix A in terms of this specific representation, which is going to assist us in trying to, of course, define this specific elementary scheme of finding matrices. So we said that we can define the matrix of an element given in terms of A. So this can be given as the difference between the sum of elements of the main diagonal given in this specific order, and the difference of that one with the elements which is going to be forming a second diagonal that runs from the top right at the bottom left. That is considering the elements of 1, 2, and of course 2, 1. Whereby these specific values are going to be representing the ith row and the jth column respectively. So in this case, this was a procedure for us in trying to determine the determinant of such a kind of a 2 by 2 matrix. And if we are going to look at this specific case for the elementary scheme, we're going to consider a 3 by 3 matrix. And we're going to perform a specific, of course, a rearrangement for this kind of a matrix and try to see how we're going to obtain this specific, of course, a set of values that are going to be giving us a determinant. So particularly, we're going to look at the two cases for the A, which is going to be giving a general representation for various elements. And we're going to look at B, which is going to be giving us a general case for a particular, of course, a matrix of a B, and try to find its determinant using the same procedure as the one used for A. So if we have A given in that specific order, we can give the various elements of A given us this specific order. So I'm just going to be quoting this element of A, and of course this is going to be 1, 1, 2, 2, 3, 3, 3, 2, 3, 1, 2, 1, 2, 3, 1, 3, 1, 2, given as such. So suppose I take the first two columns of this specific element. So this is going to be the first column, the second, and third. Now suppose I take the first two columns and repeat them and have them as the subsequent columns forming column number 4 and 5. So this is going to be forming a range of course, elements which are going to be constituting A11, A12 given as such for the first two elements of the first and second column. So we're going to have A21, A22, and then we're going to have A31, A32. So let's try to see what basically we are going to come up with in this particular case. So this is going to be forming an array of numbers consisting of this specific element for A, which we have defined using the general case for the elements of A for the ith and jth column. And the two of them are going to be additional, of course, columns which are going to be basically a copy of the first and the second column. So suppose we take the values of this specific, of course, resultant column which we are going to be obtaining, and have them given as such. So we're going to assume that basically this is going to be a matrix which is basically not a square matrix, but we're going to consider the case of this specific column which are going to be running from this specific case for the three elements of that diagonal, of course, set of values, and we're going to have them given as such. So if we take the sum of these specific elements, then therefore we're going to have these elements represented as A11, A22, A33. So this is going to be forming a product of this first set of a diagonal for the elements for diagonal 1, 2, and 3. So for diagonal 1, we're going to have a set of this specific product, and then therefore we're going to have this one as a sum of the product of this particular element. So this is going to be A12, A23, A31. And then lastly, we will consider the case of the sum of these elements of a1, 3, a2, 1, a3, 2 given as such. So this is going to be forming a sum of these specific elements which we have obtained for the diagonals, which are going to be running just as the position of the normal or the principal diagonal. And of course, I'm going to consider the second case whereby we are going to have these specific diagonals considered for the ones which are running from the top right to the bottom left, and try to see what difference they are going to be, of course, creating in this specific case. So suppose we have a diagonal which is going to be running across using, so I might demarcate them on this letter so that we can just have clarity. So we are going to have these specific diagonals which are going to touch these specific elements running from the top right to the bottom left, or the bottom left to the top right, given as such. And we're going to find the sum of this and the difference of this product of these particular diagonals. So which means that we're going to have this one given in terms of A13 times, so this is going to be A13 times A22 times A31, and then plus, so we're going to also have the sum of basically the sum of those specific of course products for this one, which is going to be giving us this one, and then A11, A23, A32, and then lastly we're going to have the sum of that one plus A12, A21, A33 given as such. So we're going to see that the difference between the sum of this specific product and of course minus the sum of the second set of products for the two diagonals are going to be giving us a particular value. And if we're going to monitor this specific value, we're going to see that this value we're going to be obtaining basically is going to be an evaluation of the determinant of this specific product which we're going to be having as a. So this is going to be the case for the second case which we are going to use in evaluating this specific aspect of our determinant, and we're going to see that whether that is going to be basically an applicable case for the second, sorry for that. So for the second case of this specific, of course, determinant which we're going to use in determining for P. So I assume that we have understood how this specific scheme is going to work. So therefore we will take the lower section for P, which is going to be a particular case for the various number of letters for B. So we are required to find the determinant of B using the elementary scheme. So we shall have this one given in terms of 2, -1, 3, -3, 4, 10. And then we're going to have -4, 2, and 1. So we'll repeat the first two columns, which are going to be 2, -1, 3, -3, 4, 10, given as such. And we're going to be, of course, finding this specific determinant using the elementary scheme. So in this case, we're going to perform the same operation which we had basically done from our first set of values. And this is going to be constituting the letters of this specific. So I'm just going to create those strokes to assist us in determining those particular products. And this is going to run that way, and this one. So basically then therefore this is going to be giving us the determinant of B given in terms of the product over this range of values which we are going to have for so this is going to be 2 by 4. Just a minute. So this is going to be 2 basically. So we are going to start with these first diagonals which we have just obtained so that we don't create confusion for that. So we'll just take our first diagonal for these specific elements and try to see what values we're going to obtain. I hope the figures are going to be legible. So we shall have 2 times 4 times 1 given in that specific case for 2 into 4 into 1 given as such, plus -3 into 2 into 3, which is going to be forming a set of these values. And then lastly, we are going to have this given as a product of plus the last product of -4, -1, 10, -4, -1, and of course 10 given as such. And we're going to have all range of these values subtracted from the, of course, the second set of diagonals which are going to run from this specific case. I hope it's legible. So we're going to have this one as a minus, which is a -4 and 4 and positive 3, which is negative 4 and 4, which is this one, and of course 3. And then we're going to have that one with, of course, negative 2, 2 and 10, which is negative 2, 2 and 10, which is going to be just a minute. So that is going to be forming our. So this is basically not negative 2. So this is going to be positive 2, which is going to be 2, 2, and of course we are going to have 10. And then that's going to be the sum of that one with the values of a negative 3, negative 1, and of course 1 given as such, which is a negative 3, negative 1, and of course 1 given as such. And if we try to do an evaluation of the sum of the first set of values and of course the second one, I'm going to get this one as a positive 35. And this is going to be forming the determinant of this specific, of course, matrix, which I've just shown at the bottom right side of my board. So this specific scheme is going to be used in obtaining matrices of a square over 3 by 3, which I've just given. And therefore, that's going to be giving us the determinant of various range of matrices, which we are going to come across using this specific approach of elementary scheme. So kindly check our description boxes for various links of other videos. Subscribe, engage us in the comment section, and also ring that notification bell for other range of discussion in math and sciences. So that is it for now, guys. Bye. God bless you. Catch us in our next video.